a string, and a list of words, all the same length. Find every place those words sit packed together, in any order. Words are foo and bar. In barfoothefoobarman, 2 starting spots work. Where? Here's the string, every character indexed from 0. Each word is length 3, 2 words, so a valid block is 6 characters, 2 3-letter pieces. Index 0, barfoo, is valid, so is index 9 foobar. We return the starts, 0 and 9, never the text. The problem says any permutation, so do the literal thing. List every ordering of the words. 2 words, 2 orderings, foobar and barfoo. Search the string for each. Fine for 2. But words can hold 5,000 entries. 5,000 words explodes into more orderings than you could ever check. You'd never finish. The orderings are the trap. We don't care about order. We never did. A block is valid when it holds the right pieces, the right number of each. Arrangement is noise. And every piece is the same length, 3. So any block is just 3-letter chunks in a row. So keep account of each word, how many times it's needed. That's a hash map, lockers labeled by word, the count inside. You might reach for a set of the words. Watch out. Word good best, word needs word twice. So count, never just check membership. 2 foos where 1 is allowed means reject. Start at 0. Take the 6-character window, barfoo. First chunk bar. In our counts? Yes. Tick it off, 1 bar, within target. Second chunk foo. In our counts, yes, 1 foo. Both match, record 0. Slide to index 1. Window arfoot. First chunk arf. Not a word. Reject at once. Indices 1 through 8 all die on a bad first chunk. Nothing recorded. Index 9. Window foobar, foo then bar, 1 each. Match, record 9. Past 12 there's no room, stop. Second case, foo-foobar, same words foo and bar. Index 0. Window foo-foo. First chunk foo, 1 so far, fine. Second chunk foo again. Now 2. The count allows 1. Too many, reject. Index 3. Window foobar, 1 foo 1 bar. Valid. Record 3. Answer, just 3. See the shift. We never built an ordering. We counted pieces. Counting doesn't care how 5,000 words are shuffled. We test about as many starts as there are characters. Each one walks the whole window. Work grows with string length times window size. The tallies hold 1 slot per distinct word. That's the memory. Remember the target counts. Each word and how many. A block is valid only when its chunks match it exactly. Remember the 2 ways a chunk fails. It isn't a word, or you've already used it up. Watch the window bound. The last start is string length minus block length. 1 passed, you read off the end. Watch duplicates. A plain set passes word, good best word. Only counts catch it. Type it up. Word length, word count, block size. Then build the target counts. Loop over every start. Fresh counts for this window. Assume it's valid. Chop the window into chunks, 1 word length at a time. Reject if the chunk isn't needed, or its count runs past the target. Survive the inner loop. Record the start. Return them all. Any permutation sounds like order matters. It almost never does. Count instead.